like the service monitor mechanism and all of that, but for monitoring our own infra, which includes Cortex Loki and the clusters, we want to deploy the entire stack additionally via Tanka instead of via the CoreOS Prometheus operator. So many of the charts that we're installing today have either service monitors or other endpoints that need to be scraped. So it seems like I need to learn a lot more here, but this is a bit of a game changer for us in a good way.
That's fantastic to hear. We can say it was actually Chart Manager that Cert Manager rather was the one that led us into this. It's such a complex chart. We have forked it, and then we dug ourselves in holes, and this is how we got here.
That's why we did customize for the same reasons. We're running Cert Manager with Let's Encrypt for all of our stuff, along with external DNS to Cloudflare. So those two form the basis, combined with Nginx, of all of our ingress management and cert management. And yeah,
I can speak a little bit to Flux. I've just been working on deploying a lot of our internal clusters with Flux. And the way we're doing it is not with the transform functionality that's going away. We check in all of our Tanka environments to our main repository. We have a CI job that runs essentially TK export in parallel and spits them out into another repository that is just for the raw Kubernetes YAMLs. And that is what FluxWatch is. And so really that repository could be generated by Tanka or Helm or anything else you wanted to. It's kind of just manually doing that transformation phase. So Flux doesn't have to.
That's what we're doing with Cortex today, but we didn't have time or energy to learn JSONnet and Tanka when we had to put Flux in production last quarter. So we emitted that once, checked it in, and we have a whole bunch of customize on top of that to add in annotations and things like that. And in the last 2 or 3 days, I've been backfilling that and converting that all to Tanka, so I don't have a nasty 3-way merge every time.
We are still kind of fighting through a lot of the logistics of, okay, our main workflow is you export it and Flux takes care of it. But then how do you also have like a TK diff workflow for development? And can you do TK apply on an emergency without Flux overriding it? So still kind of working through a lot of this, probably a few blog posts to come out of this once we figure out how it all works.
We're doing the same. We're working on a GitHub action and same challenges. I'd love to talk when there's time outside this meeting if you're up for it. But yeah, that's active work right now. Last night.
Sounds very cool. All right, I suggest we could go on with the next topic. So Malcolm, do you want to say something on JSONnet tips?
Yeah, okay, let me share my screen. So some of you will have seen this before internally, but this is something I want to make a blog post about. Fortunately for the people here, I've realized that the complicated bit was unnecessary, so I removed it. So basically, what we've got, this is an attempt to communicate some of the lessons we've learned from using JSONnet internally as a language. I could say we've inherited some ways of doing it that have not served as well as they could, and these are ways we've worked out that use the language more effectively. So first thing to say, this is not intended as an introduction to JSONnet. It assumes you know JSONnet and have some experience of actually, you felt some of the pain already. So what's the problem? So it's a very flexible language, perhaps too much so. So it allows to create unstructured code. So what do we do about this? Well, then Matt's saying he's 3 days in. Hopefully this will really help. So the way we solve that is by adopting some conventions. So, for example, in Golang, we could just write our entire program in one large main method or one large main.go file, but we don't. So in any language, we can adopt bad practices, but we don't, because no one ever does, and we copy what everyone else does. So in a way, this is presenting some conventions. So we're not going to cover the journey here. I forgot to remove that word. Let's get going and have a look at it. So first of all, syntax. So let's just have a look at a few things to do with syntax that will be useful to know. Here's a stupid one that Tom told me a while ago. Colon. We might think colon means public. It doesn't. It means inherit. The default is public. So when you use colon, you're picking the default value of public. So colon means hidden. So if we say this, which is hidden, plus this, which we assume means public, we get this, which might be somewhat different to what we think we would get. And that's one we could easily find ourselves bashing our head against that for hours. There's a very simple solution. Use the triple colon, and suddenly you're saying, take the hidden thing, make it visible, kablam, you've got your nicely merged JSONnet. Okay, that's the first one. Second one, if you're debugging, well, you can use the tk eval -e, but sometimes it's nice to do, you add, as you're writing Golang, you might add format.println, etc. into your code. But how do you do that in JSONnet? Well, one way you can do it is emitting trace messages. So all this will do is print some message, and then it returns the value. So effectively, this whole thing here is equivalent functionally to that chunk there. So you could include in the some message, a JSON manifested version of your data as well. Yeah, but it can also be used for deprecation messages, as seen in this example here. Commas and pluses. I'm not sure whether pluses has a 2 S's or 1, but I think you'll get the point. So if we look at this code, what we're doing is we're taking mylib .new, creates me a new version of mylib. Then we add on to it, we call them the mylib with a function called with something, which gives us a patch to the original. And then we do another one that adds something else on. So this is all perfectly reasonable, except when we comment out one of them, we get invalid code because there's an extraneous plus on the end. And you can end up spending lots of time faffing with those extraneous characters. Whereas if we do it this way, stick the pluses on the beginning, suddenly you can comment out a line, and it's really not a problem. Now, what I do accept is there's likely religious wars over whether that comma should be dangling or on the end. Yeah, I think we could have many, many arguments about that, and I'm quite happy with that. But the idea, at least, of having the pluses at the beginning makes life so much easier. Extensible library. So how to create extensible libraries. So a few things. So I'll say these briefly, but this call is being recorded. So and I will be making I believe I'm going to aim to make a blog post of these points at some point. So first of all, there's a tool that Tom's created called Docsonnet, which you can use for documenting your libraries. Provide a clear config. So how do you configure your library, and how do you make it easy to extend? So I think what I should say for this audience particularly is, what is a library? So for example, a library could simply be, I want to install MySQL. So I'm going to have a library which could either be in my /lib directory or vended in from GitHub in my /vendor directory. And it's an encapsulation of some functionality. It wraps some functionality that I want to consume in multiple locations. So if it's vended particularly, we might want to make it public. We might want to document it and have public documentation about it, hence Docsonnet. We also want to have it having clear inputs. And this being JSONnet, we want it also to be easy to extend. So let's have a look at those three. So here is the current version of Docsonnet, which takes a little bit of picking apart. So if you see, we've got an element here in quotes with a key in quotes beginning with a hash. And it calls D, which is the Docsonnet library. It says the thing that comes next is an object, and here's a description of it. So the next thing is an object. It's called myObj. Oh, here is myObj. And the same thing here. The thing that comes after me is a myfunc. Oh, look, there's myfunc. And we say, look, it's a function. And here's a description, and here are the arguments. Yep, and the arguments is just so the first argument is a who, and we're telling it's a string. So suddenly JSONnet becomes typed. Yep. And you can see an example here of our KTS alpha library that uses this extensively. Here's a simpler version using comments. I don't know, Tom, is this app public yet, or is this still in development?
It is public, but it's not merged yet, so it's
Okay.
a branch on the project.
So it needs to be merged into Docsonnet to do this. Okay, but I think you'll look at that and think actually that's much clearer. And the structure here is static, but certainly can. So you can certainly start using it whether we've finished the code yet, the Docsonnet code yet or not. So moving on to library configuration. So how do we pass in? So at present, you know, this is a common practice is to use a global root $, add everything together, and then reach it from a library. You just reference $, and you go get a value from the root, and that's just a mess. It creates really complex code. So what we do is we make sure we encapsulate the library with clear means of invocation and pass in everything to the libraries rather than referencing $. But bear in mind, $, means the root of this particular tree. It's not the root of the whole tree. So we may still use $, and that's referring to the root of the library, especially if the library is within a local. So $, isn't always evil, although it can be sometimes. So let's look at our library. Here we've got, so I should just say that $, here, if you see here, $, is referring to the root of the current tree. So here we have $_config is referring to $_config, and then .replicas goes and gets this value. So here we're configuring a Grafana. You know, this is very much pseudocode, and it has one value, Grafana replicas, and that value comes from a hidden config. Then we have a function called image, which is hidden, that returns a single element with a key of image and a value of whatever we passed in. So this is how it's typically done. We create a local, but we add local to the root. There's an implicit plus here. So we've got this block plus the Grafana is all smudged into the root. And this is what we're suggesting we don't do. So if you see here, we've got plus, we've got Grafana plus, we've got, if you see, we say whatever comes out of this will return a Grafana element, and to that Grafana element, we're going to add an image, the output of this function. So we end up with Grafana, that's what was in there before, and with image, it adds in image. So you've got this nicely merged output. So plus has merged what was there before here with this here. Yeah. So if you have questions about this, please note them down. Happy to answer them at the end. So this is another way of doing it. So here we have local Grafana. instead of adding it to the root, we create an element called Grafana, and we import the function in here. And then the implicit plus means this plus this. So we add another config element. This plus means don't overwrite the element, merge this config into whatever was there before. So we can just override specific config elements. So here I'm setting replicas to 2. So instead of having replicas 1, we should have replicas 2 instead. And then we add on to that grafana.withImage, and we get this. You'll notice in the tree is Grafana, but that doesn't matter to Tanka because Tanka strips out all of this. It only looks for the Kubernetes objects anyway. Yeah, so the JSON might be slightly different, but that's really of no consequence. So moving on to patching. So now what we've done is we've executed, invoked a library. We've handed it configuration, and we've invoked it. Now we've got some JSON back, and we want to do something with it. So as, for example, Tom was saying earlier, with the Helm support, the library could, instead of just creating Kubernetes resources, it could call Helm, which creates the Kubernetes resources for us, but we then patch them. So how do we do that? So patching JSON objects is easy. You just do plus. Patching lists is hard. So it requires you to iterate over the whole list, which is really annoying and messy. So there's 3 solutions. I'll show you through them rather than read them here. So here is a library. So this library simply lists products, some products that we have. As you can see, Tanka is currently more popular than Grizzly, but I'm doing everything I can to sort that, as you can see. So the problem we have is someone else has just clicked on to like the project. So we need to patch this to represent this. Okay, so how do we do that? Well, at the moment, this is what we have to do. We load in our Grafana Labs library. We say our Grafana element plus Grafana Labs. So Grafana Labs, whatever comes out of that library, plus this patch. And this patch says products, and then this array. And then it says for everything in super.products. Super is the previous block to me. So go through everything in this here, all the products in here. And then if the name is Grizzly, then increase the stars. Otherwise, just return to E. That does in fact work, but you try reading that code and debugging your way through it. Yeah, it gets really quite hairy. Whereas if we, so it requires iteration, replaces all elements, it's complex and fragile. So that's the problem with it. Have a look at this. What we've done is we've created 2 hidden elements, Tanka : blam, Grizzly : and we've created a list from that. So I'll say more about this later, but I call this late binding. You create the list, that you create the data, the result that you actually need late, and you give yourself points that you can interact with it internally. So now we just import Grafana Labs plus Grizzly, merge in this to whatever's there already. It stays, but the Grizzly thing is hidden, so we stay hidden. And we set our value of stars to 48. Okay, I think you'll agree that that is a lot cleaner than that one. Yeah. So really, it's a question of using some form of internal data structure. So this really works well when the number of items is small. When the number of items gets bigger, we have to do something else. So what we've got here is we've got a product map. and this can have as many items in it as you want. And here, instead of just adding specific elements, what we do is we do another loop for t in. We get the object fields. That is just the name, so Tanka, Grizzly, iterates over them, and we just then go and get the values out of this array. And we can still do the same manipulation as we were doing before. This time we go and edit product map and edit Grizzly. Yeah. So this works well when there's a large number of items. You know, in here, you know, you could load in another library that has a whole load of patches and add that patch to the library. You know, so much you could do here. What about when order matters? Hang on, did I skip something? I think this is in the wrong order. It's got in the wrong order. So let's say what we want here is, I think Grizzly is more important than Tanka. I would. So therefore, it needs to be first. How do we do that? Because maps aren't ordered in JSONnet. So stolen from Stanislav, one of the maintainers of JSONnet, what you can do is you can maintain a product order, a separate list which restores the order. Then what we do is we iterate over that list and then return the items, and you get that. So, and we can still using this, yes, the slides are got in the wrong order. We can now patch it in pretty much the same way as we did before. Just to say, I did say that this was not an introductory JSONnet presentation. It's pretty full on, but it's really useful things if you're going to be spending time making lots of libraries. So this works when the orders of items matters. We might most likely want to create a little library so that when you add an element to it, it actually adds the library will add it both to the map and to the order. So rendering late or late binding. So I've said this here. So this is the thing we really want, but what we're doing is giving ourselves these. But this thing is really hard to patch because it's a list and it's just messy, and maybe it's a Kubernetes object and it's like 15 layers deep, and so you're going to have to do this dot this dot. You get this horrible tree. What we can do is we can expose, for example, this is a common use of this is in containers in Kubernetes. Is put the container, so MySQL underscore container ::, as a hidden element, and then in your deployment.new square bracket, and you list $.MySQL container. And suddenly you've now got an entry point where you can say, oh, add this environment variable to this container, etc., etc. Suddenly you're, rather than embedding it into the deployment.new, it becomes patchable. You know, here's a rough example of, you know, an example of how that could work. You know, we're iterating over the same thing. This is not valid code, but you get the idea. We can iterate over all of these and create our config maps. So moving on to the next thing, mixins for extensions. So if you, let's say, for example, we have I've seen this a number of times when people say they want to extend a library. So we have Prometheus case on it. And they say something like, if config is HA, then do this, otherwise do that. In JSONnet, what you end up very quickly is you end up rewriting Helm charts, which is just this smudge of if this, then that, otherwise do this, but not that. And oh, but if you do this and that, then, you know, it becomes very confusing very quickly. A much better way to do it is to create a mixin. So Prometheus creates a default Prometheus and Prometheus case on it mixin in setup. But here we add on this mixin. So a mixin mixes in to something. So this is not a valid resource in itself. All it knows is how to convert this into something that does Prometheus HA. So this will install a single Prometheus. This will install a Prometheus HA pair. And this way you can have mixin after mixin after mixin after mixin, and they can, at least in theory, if you construct your initial library right, they can all just merge into one happy family. So what this also does is this keeps the knowledge about how to adapt your library in the library. So what it's common to do as well is you have this library which makes you a thing, and then over in your main.jsonnet you add this huge JSONet patch, which is not actually consumable by anyone. It's like you can't make sense of it. So take that, put it as close as you can to your library, and then you call that as a mixin. So you just say MySQL plus MySQL with some super feature enabled. And then I'll say more about that in a minute. Avoid this pattern, which you may have seen on Kubernetes libraries, new with something else, etc. Because not because it's inherently bad, but it just breaks the JSONet interpreter and makes your code much slower. So use this model, even though it's slightly more verbose. This plays to the best of JSONet. So a couple of last points, some of which I've made already. Try and make your main.jsonnet as clean as possible. Push your logic as much as you can close to your libraries. Consider your environment to be your specification. Your environment says this is what this particular environment should be doing, but you don't really want code in that. You want to push that as close to the libraries as you can, potentially with mixins. So with dev mixin says, okay, right, remove authentication, or without authentication, or etc. mixins. So let's keep going. So first of all, push logic close to the libraries. So here we have Grafana plus Grafana with some feature. Really clear what you're doing. Yeah, I have a Grafana and I have a Grafana, and I've enabled a specific feature. And it's easy to see how you can disable that feature now. And you don't have this situation where you've got a huge blob and you don't really know what it's doing. Or we could, let's say we're doing a lot of things in a main.jsonnet, we could actually in our main.jsonnet have a separate load of files in our environment and import them. And we then know that all of the stuff in this file is related to Grafana. Great. This is a rule of thumb for me. If you can avoid importing k.libsonnet into your main.jsonnet, I would say you've done really, really well. Because the fact that we're deploying all of this to Kubernetes should not be relevant to your main.jsonnet. It's a specification of what you're doing. The fact that you're using Kubernetes or k.libsonnet is really something that's more relevant to your actual library than it is to your main. Abstract environment, something that Tom named. Most libraries create an application such as, say, MySQL. But what if you've got a website and you want to have a staging website and a production website that's hosted on WordPress? Actually, you can create a lib, but it's an abstract environment. So it's a website. And what that does is imports the MySQL lib and imports the WordPress lib, and you're done. And that would be an abstract environment that can be configured to do different things in different environments. So congratulations, you made it to the end. Any questions? But I suggest we stop there and open up not just to questions about this particular presentation, but everything that we've been shown here. Thank you.
Right, question time.
What the hell was that all about is a valid question.
That's good to hear, Matt. Feel free to reach out anytime on the Slack channels or the mailing list.
Yeah, like literally last night I was plumbing out again, we're deploying Loki and we've already got Cortex running. And for example, when we run Promtail, we have a default service account that we don't use. So we make service accounts for everything because the default pod security policy, which we name ZZZ dot whatever, because Kubernetes is weird and alphabetically that one will be last, has no rights at all. So if somebody doesn't specify a service account, you get a pod security policy that says deny everything, right? So I was looking, how do I patch in support for pod security policies and then make additional annotations or changes to the existing cluster role bindings, cluster roles, and service accounts. And I kind of teased it back through, but I've got things like that, as well as things like adding annotations, which I sorted, but my main.jsonnet is just like a gaggle of patches. And I have to actually import the ksonnet stuff so that I can reach in and add an annotation to memcache or to console so linkerd proxies aren't injected or whatever. Or we're also using annotations on service accounts. This is the one that I still don't have solved, and I think one of your tips gave me an aha to add EKS, AWS ARNs or roles that are to be assumed by a service account via annotation, so that service account can, for example, write to Dynamo or S3. So some of the things you presented really framed it for me. Again, I'm super new, so most of my questions are newbie grade. But,
Right.
Thanks.
Cool. So
Right.
Tarask asked, is there a best practice to do conditional imports or mixins based on a var value? So I guess you mean an extvar with that. I guess there are no best practices for extvars in general because these are considered an anti-pattern by the JSONet project itself. So these were added several years ago and have posed to be challenging because when they are used throughout a project and set or may not be set, it might become challenging to understand where they are used and what effect they have on the outcome of the configuration. So I would be interested to hear your use case, and maybe you could explain a bit what you're actually trying to achieve. Maybe there's a better way that does not involve extras at all.
I mean, I guess the scenario is simply: do you want to, if you want to say in one environment something switched on and in another environment something isn't.
Yeah, sorry guys. I was in
okay.
a noisy office. I just couldn't get a spot. Yeah, so that's precisely it. Instead, we use our continuous integration system has basically all the information about the environments, and in Tanka env is just basically the target cluster configuration, and we're using. And this is to stay compatible with some other patterns that we have. We're using these external vars to switch on and off various features during testing and before things kind of go out. Right now I have basically imports doing if-thens. I was just wondering if there's a slightly better way to control imports and mixins.
If it's like more or less stable, what you would turn off or turn on for certain environments, it might make sense to actually have these as environments. So for example, we have multiple layers of environments. We have a first layer, which is application, and then we have a second layer, like subdirectories in the application environments, which are regions. So maybe you could have also on application, then on feature levels or something. Or if you really want to use late binding, you should probably check out top-level arguments because that's the designated replacement for external variables.
Okay, yeah, gotcha. That's something I was actually looking into as well. Okay, cool.
So just on that again, the difference between extvars and top-level arguments is that extvars are accessible from everywhere in the code, which makes it challenging because, for example, a downstream library you didn't even offer might react to an extvar being set without you actually realizing, and code might break if you set it or not set it. While top-level arguments are only permitted in main.jsonnet and happen at the in a very defined way. So instead of having an object at the top level of main.jsonnet, you just need to add a function there, and then you have function parameters on that function, which either has a default value or is required. And then the JSONet interpreter prompts you to set that variable.
Yep, makes sense. Thank you.
Cool. Any more questions or
But
feedback?
it is worth noting that it is difficult to do imports dynamic imports. JSONnet deliberately leads you away from dynamic imports.
Yeah, so I've noticed.
Yeah, I had a similar question. Like, so I'm doing all of my work now just on one cluster, but like I said, I want to replicate this out across our fleet, and I don't want copy paste in main.jsonnet. Is there a notion of nesting with libraries that I should be aware of? Like, you know, I could take everything that I'm doing that's like one of my clusters, which, you know, for you know, is really a bunch of scrape configs, Grafana, Prometheus, just a whole bunch of junk, plus some stuff that we're layering in that are patches on those things. So I'm already like importing libraries, but if I wrap all of my stuff that's a cluster into a library and then reference that from my dozen main JSONets, one per
Exactly.
environment,
So
do I run into some kind of like nesting recursion problem where JSON is going to blow up, or is it just happy to just glom it all together?
That's the power of it. Is what it does better than Helm is it adds sort of semi-infinite recursion and abstraction. So you can build large data setups. So you can have a very small main that just says these are the key features that are switched on or off, and then in your abstract environment you describe that whole environment, that whole namespace, and everything that goes into it. And by doing that, you reference the libraries which give you your individual applications.
Right, abstract environments are probably the key thing here. So to differentiate these from libraries, a library would be something very focused. For example, a library for MySQL or a library for Nginx. So these deploy a single piece of software and optionally set some default values, but not go much beyond that. While an abstract environment, it's technically not different from a library, but logically you define how an environment looks like without actually having all of the environment-specific data in there. So, for example, say we wanted to deploy Loki to 4 different regions. We could have an abstract Loki environment which holds all of the setup. All of these 4 region environments should be comprised of. And then in the main.jsonnets of the respective real environments, we would only feed in very environment-specific information such as secrets or IP configurations and stuff like these.
Yep. Cool.
Right. You know, and another trick that Tom's been doing as well is, or showing me, is you can create an environment and then you can actually create another environment that consumes that environment. So it may be that you, for example, what Taras was saying about wanting to switch something on and off, you could actually have you have one directory which says here is our environment, but within that directory is another one which contains a main.jsonnet which imports the /main.jsonnet and patches it in a specific way. And then so rather than handing in values, you can actually call different directories for different outcomes.
So this is what we're doing with customized now. I mean, the same metaphor. So we're running Grafana Enterprise, for example. Everything we do is staging in prod. So I have overlays for staging that just bump an image tag or something like that. So that's great.
Yeah.
While this is probably a cool thing for just getting done something quickly, I would generally say that if you want to build something sustainable, you should not have one environment depend on the other, but instead do the thinking to properly abstract out the things that apply to both on a higher level, and then both have them consume the higher level thing. So these are both first-class citizens.
Yeah, that was the next thing I was going to say. You know, the one environment importing another is a useful tool for working around some edge cases, but not the best practice. Use abstract environments in lib for that.
Yeah, I guess that's what I meant. So with our customized configuration, we have a base configuration that most of the configuration is in, and then we only have minor kind of patches to try on new features or enable feature flags or things like that.
Yeah, and you can make those. You can make those patches if they're just fixed patches. You can make them hidden on the main library, and then add it in to the library, and so yeah, or you can make it a function on the library so that it just can be then consumed. Probably look at the when this call recording is shown. Have another look at the slides I put up because it's all in there.
I had one last question. I spent some time last night debugging the old Heptio VS Code plugin for JSONnet and found the many ways it breaks. One of them is rendering web pages, and the other is it blows up its stack attempting to grok Kubernetes Alpha. Are there dev tools that I haven't found yet to either just make editing and or authoring JSONnet easier?
The death of the VS Code one is a real shame, and if you or someone were to fix it, you would become extremely popular in this part of the world.
I forked it last night and started figuring it out, and then I realized I had to go to bed because I had to wake up today for stuff. But
Right.
yeah,
I'll now just muse on the fact that there's always tomorrow.
Yeah, editor tooling is a real problem, and we all just use plain Vim or Emacs or whatever we have at hand to modify JSONnet files. There are some plugins to at least add syntax highlighting and indentation ruling, but that's mostly it. There's no such thing as a debugger or...
yeah.
Well, the probably best thing to debugging JSONnet is writing code that does not need debugging, even though that sounds like something magic. Like it's easy. Like, it becomes easier when you try to keep code simple. So not do a lot of computation, avoid using if else, try to use mixins more.
Yeah, right now. Yeah. Right now I just do a TK export and a TK eval, and I dump them to files. And the manifest, so whenever we change JSONnet, like the manifests also are in that same commit. So you can kind of see this JSONnet changed and it had these outputs, and then Flux picks up the raw stuff. But my debugger has just been running a script that does that and then uses Git to just see what the changes are. It works, but.
Right. Sounds totally valid.
I'll see what I can do on the other thing. No promises on the plugin.
Definitely. It'd be super cool to see somebody pick this up, because this is like we're frequently getting complaints and issues on the plugin we did not even write, but so apparently people really want to see it again.
Well, my partner, my girlfriend right here is still at VMware, and so I know that the Heptio folks inside VMware still like JSON a whole lot, but I think they're working on other things. So
They should reach out to us.
There's still plenty JSONnet in the world.
I don't see a better choice. We looked at JSONnet and Tanka. Before Tanka, we looked at JSONnet Customize and Helm a year and a half ago, and I kind of cried a little bit when they mothballed JSONnet because Helm kind of sucks. Having used it at scale, it's brittle and awful.
Just for the record, you mean KSonnet?
So no promises made.
Yeah, it's just, yes, I'm sorry, I misspoke.
Yeah, no promises made that this will ever be a thing, but there is something in development, not from us, but from some probably very clever people called Qlang, which aims at revolutionizing config management using lessons learned at Google. So maybe in 1 year's time, this might be a cool thing. Definitely worth keeping an eye on it.
Awesome. Is it just Tanka or Tanka Dev where the Helm stuff is going to be talked about moving forward? I'm extremely excited. I know.
Yes, Helm docs are now on Tanka Dev/Helm.
Cool.
You can also drop
Thanks.
in the Grafana Labs Slack channel, and there's the Tanka channel in there if you want to chat.
Awesome. Thanks.
Sure. Always cool to see people use it.
Yeah, I think our biggest challenge still is unifying service monitors and the Prometheus operator. I know it's not really a Tanka thing, but I was kind of hoping that, right now we're using that for everything. But as I said, we want to cleave that and just let other teams use it so they can self-declare. But there's a lot of infra things where the Helm charts declare service monitors.
Oh, when using the Prometheus operator, you really should not use the Helm chart, but keep Prometheus, which is the JSONnet library of the same authors. So
exactly, yeah, we were new, so we were using that whole rendering the Prometheus operator out just to get it working, and then suddenly we had a dozen clusters. So we're refactoring things now. But we have now, dozens of services writing service monitors to say, "Come scrape me." So, that actually is working pretty well. But for our own infra, we've decided, as I said, to be able to unify. So like we've got Cortex, but keeping dashboards and scrape configs in sync is a bit of a pain. So we're hoping to just emit everything with JSONnet and then use it as a way to show our teams like, hey, if you're writing net new things, here's how you can bundle dashboards, your metrics, your scrape configs all together in a mixin. But I think we're still a quarter away from knowing it well enough ourselves to teach it to our teams.
I would kind of throw in the caveat that we made the Helm integration as more of a compatibility shim, so we could use Helm charts rather than like, we think you should do Helm workflows with this tool. Like, I would definitely advise against having new teams writing Helm charts for use in JSONnet.
Yeah, I was talking about a couple things at once. I actually meant for new teams just doing just JSONnet. I see this more as a migration path where I can go from, a bunch of existing Helm running some core infra stuff and, bring it into JSONnet. And then over time, because we're a tiny team at my company servicing the whole company, we can kind of piecemeal age out Helm and replace it with JSONnet. But
sounds really practical.
Framework that's, yeah.
I'd say the Helm integration of Tanka is working far better than we originally expected. So it's definitely valid to use that as a migration path. Even though to use the full power of Tanka, you should definitely start writing as much as you can in JSON at some point. But for the time being, it's probably a very valid thing to use what you already got and onboard that onto Tanka.
Yeah, the way I framed it for myself is that we're running us, we've gone over time, is simply that if you're installing something that you just need as a side tool, use Helm. If you're installing your own application, use JSONnet.
Right. As we are basically at the end and over time, I will stop the recording now.